Hey, Brian here from quantlabs.net. Just going through this options on futures continued with certain examples. This is video number 18, and we've got our Python code here. Try to make a C++ version of it. But let's just still walk you through the different types of examples. So again, this is from this video, UC Davis course, Futures and Options, video number 18. Options on futures continue with examples. Okay, so again, in the source code, we've got here a series of strike prices. We have a series of call May contracts, and then we have equivalent puts. Okay, so here is the time that I'm specifying. And here's some blurbage on what this guy's saying, the professor here. And I'm not going to go into the comments, but basically these are just examples of, I'm just clear out these breakpoints here. Okay, so I'm going to debug this as we go. So what I'll do is I'll set breakpoint there, start debugging. So what we're doing here, we have a contract size of 5,000. Premium is the equivalent of whatever the call December is, and I believe it looks like it's 56. Oh, yeah, let me just debug this. Okay, so our call December is 1125. It looks like, with a contract size of 5,000 here. So our premium would be, as it says here, 562.50. We also have a settle price of 240. He talks about that. This time at 548. Another example he sets, just to showcase how this works with intrinsic value and whatnot. Basically, intrinsic value is the difference between a future and strike, and that depends if it's a call or a put. So it's the opposite if it's a put, I believe. But let me just show you here. So we have our strike price at 250. Our future is at 240. Now, because the future is less than the strike price, that means that the option has no intrinsic value. Okay, so let's run that. So we know our future, as I said, is at 240. Our strike is at 250. So print has no intrinsic value. All right, next example. We have a March future of 246. I believe, which one is this? Is it a call or a put? As it gets closer to expiry, option will expire before futures, but depends on contract and exchange. Look at market March calls. So these are what we're doing, our March calls as an example, and the premium will fall as strike prices go up. Now again, I should highly recommend you watch that video to get the full detail of it. So we set our March future at 246. Our second strike price that we're playing with is at 240. So for March future, for the call, is if the future is greater than the strike price for a call, then it has intrinsic value, and the future is greater than the strike. So there you go. It does have intrinsic value. And typically what you do is you exercise as it approaches expiry, where the intrinsic value is equal to 6 cents. So that's the difference between, where are we? 6 cents. Yeah, so as a March future minus the strike price, that's for a call, and the opposite takes place for a put. All right, so our next example is where we set the May future, and if they're equal to each other, which they will, so our future is, so our future set at 250, we set our May future at 250, so this is going to be at the money. So at that point, you can exercise it. Where's my execution? Okay, so let's check that out. So we know that the strike is equal to the May future. So as a result, so our May future and strike are the same. So this is what we call at the money, because the intrinsic value is 0 and you can reverse the position. So our next example is if the future is greater than the strike, then you are moving into the money. So we set our February price, future price at 30.50 with a contract size of 1,000, which is barrels for oil. Strike is at 31, and our February put is at 193. So our premium total is the put times the contract size. So we'll just run these. So we know our total premium. So that will, total premium is exactly as I said, with a right to go short. And that is, so we're going to go short on that. And that's that. Okay, so the next example is where we have a future set at 246, call option at 250, intrinsic value, because it's a call, is call minus the future price, and we're just calculating our intrinsic value at 4 cents. Okay, so the oil face value at 1,000, so the premium's at $1.93, total contract size is 1,000 times the premium. So we know our total contract size will be 1930. Okay, so the next one is, if you bought a put today, exercise a short position at 31, you can reverse at 30.50. So here's our intrinsic value. So our strike is at 31, our February is set at 30.50. So our intrinsic value is 50 cents. Now here's the thing about time value. Time value equals a premium minus the intrinsic value. And just to note here that the time value can either be only 0 or positive, never negative. So let's display that. So we know intrinsic value 50 cents, time value at $1.43. So now this is where it gets tricky, because now we're moving from agriculture, like corn, to let's say oil. Now we get into more of the financials using the Japanese yen. So we know our contract size is 1.25 million. That's $1.25 million price per yen. So here, if we set a strike price in yen, this would be quoted, can be quoted in, let's say, the Wall Street Journal at 91.50 minus the decimal points here. Also, for December call, you get quoted at $1.18 per, here's the key, 100 yen. So you have to convert the dollar per yen, or you have to convert it by multiplying 100. So also our premium is $1 per yen. So this is how much in dollars per yen. So what we're doing now is calculate the premium times the contract size of this at 1.25 million to calculate the total premium. So let's do that. Okay, so there you go. Yen example is 14.75 for total premium. Now, T-bonds is even wonkier. We have a face value of 100,000. Future price is always in 30 seconds. Okay, but note that options are in 64ths. So you will have to divide by 2. So if you have the original quote at 31.24, divide by 2 to give you 15.62. And also remember that strike price is a whole number. So we know our option premium is at 15.62. It's calculated here. And that is for each 64th. So our strike price could be 107.9. You may need to convert to 30 seconds if needed. Now, a December call will be quoted at, let's say, 121, or also saying at 121 64ths. So this is how you calculate the total premium. You take 1 plus the 21 divided by 64 times 1,000. And that is where the note of this thing right here, this 1, actually represents 1,000. Okay, so knowing that, let's calculate our total premium. So there you go, 1328, 125. So this is an important one for working with treasury bonds. These notes here. Okay, so now we're going to do call options where you can long at strike at 107. So we set our strike at 107, and we have our December futures again using that. The strike at 107 times 24 divided by 32, or 30 seconds. So I'm not going to get into these notes here. So what we're going to do is we're going to try, in this example, try to calculate our intrinsic value by taking 24 divided by 32. So that's what we're calculating here, the December futures, see if it's greater than the long, to see if it's in the money. Now, when we run this, IV, the intrinsic value is 750. Here you'll note some confusion, so we just ignore that. Our time value is the total premium minus the intrinsic value. Okay, so print them out, so we know that our intrinsic value is 750. As you can see here, with a time value of 578 and 12 cents or whatever. Now, here's an example of a call option being out of the money. Now, remember that the December future, which was defined up here, or where am I? December future, where are you? Well, it was defined right here. 80.25, I believe. So we set our strike at 108, which is greater than the December future. Therefore, we are out of money. That's it. All right, so there you go, an example with oil, corn, yen, and treasury T Bond. All right, hopefully I'll help you out. Oh, and if you want the code, just join my Quantly membership. We got lessons on this stuff. All right, talk to you later.